Okay, so the uniform probability model is as follows. True story, went to my basement last night and it's full of water. So I've got a leak in a pipe, call the plumber. Plumber says, I'll be here between 1:30 and 2:30. So I say, well, look, I'm going to be in class. I'll send somebody over to stay there. Can you tell me when between 1:30 and 2:30 you're going to be there? He says, no, equal probability in those 60 minutes. Every minute he has the same probability of being there, getting there. So I say, okay, well, let's see. Now, I'll just say 0 minutes past 1:30 to 60 minutes past 1:30. He has a uniform probability distribution being there at any particular minute, and it has, of course, the same probability. I can figure out what this probability is because the area under the curve equals 1. So if I have a length of 60 here, and I have 60 times what equals 1, I know this what must be 1/60th. So in other words, I have a probability of 1/60th, which is fine. And really, basically, it'll be 1 minus and then whatever b minus a is, right? Whatever this length is. In this case, 1/60th. Well, that's fine, but I really don't need to know that for uniform probability. I told you that it was the easiest one, and here's the idea. What's the probability that he'll be there between 1:45 and 2, so that's between the 15 minutes and the 30 minutes. Well, let's see, there's 15, 30, 45, so I have 1, 2, 3, 4 parts. We're talking about 15 minutes out of 60 minutes, or 1 part out of 4. There's a 1/4 probability that he'll get there between the 15 minutes and the 30 minutes. How about between 15 and 60? Oh, okay, well that's 15 and 60. So they have there's 4 parts total still, and there's 1, 2, 3 parts out of 4. So basically, if it ever says, you just have to recognize the vocabulary. If you ever see uniform probability, then you know that it looks like a rectangle, and you can basically find the probability by computing the area just by dividing the rectangle up into parts.